right. Well, first off, thanks everybody for showing up today. My name is Charles York. I work for Snowflake, and I have been here for a little under 2 months, which is actually kind of long for Snowflake, given as much as we've grown quite a bit. But I've been doing data warehousing analytics, both as a consultant and practitioner, as well as worked for companies like Pivotal, who have the product called Greenplum, as well as MicroStrategy, in various roles from product to sales over that time as well. So I've been around this for a long time. Grew up in Midland, Texas, so very well versed in the oil patch, if you will. My dad worked for Devon for a long time, and so anyway, so I'm actually coincidentally up here today to help them move from Edmond back down to Dallas because they were tired, so they're going that direction. But anyways, so what I thought I would do today is go through. I know that I guess maybe just a show of hands. I know it sounds like a lot of y'all are currently using Snowflake. So who all uses Snowflake currently, right? Okay. So some of the stuff I'll go through, you guys will probably be like, all right, yeah. But for everybody else, we'll kind of give them the lay of the land about what we are, what makes us special, and then we can go through some demos. We can show them some neat features, and you can show you some things where we connect, Jupyter notebooks over to it and how that works and everything like that. And then also discuss in the realm of ML and AI where we play, right? And I think that's a good place to start before we even talk about, what Snowflake is. But as you probably well know, when it comes to true, data science, AL, ML, AI, whatever you want to call it, I mean, there's still a vast majority of that time that's spent on data cleansing, data prepping, feature engineering, all that kind of fun stuff, right? And it's, for most folks coming into that, kind of realm, they know SQL, so, trying to use Python, trying to use Scala or something like that, trying to learn that can be pretty painful for a lot of folks. So being able to use a tool like Snowflake and just do a lot of complex kind of, transformations and cleansing and some of the unique things we do with data cloning and things like that to actually prep data, make it a lot easier for somebody who's trying to get into that. Obviously, we're not in the business at this point of, actually executing proper models inside our database. We can do push down technology with some of the other things, but we're more, I would call us in the data prep in your data warehouse type world, right? And then you're going to actually run those models, say in a Spark or a Databricks or something like that, right? I heard you guys talking about Delta as well, right? So that's an interesting topic, and we can talk about that later if you want to, and understand where that goes. But feel free to jump in, ask questions anytime. We won't slide you to death, but we'll kind of start with this. So let's see here. Well, that's not good. We can get that over here. All right. So, Snowflake for y'all. Those of you who don't know, let me see if I can get this out of here. Get out of Windows. All right. So, what we are, as most of you are probably well aware, founded in 2012. Three guys, and it was mainly start of it, but two of them came from Oracle as basically kind of the developers of the engine, some of the core engine development from Oracle. Decided they didn't like Oracle, decided you guys probably have all dealt with Oracle at some form or fashion and the pain that can come there. And for data warehousing purposes, it just wasn't cutting it, so they left. Built their own, kind of database from the ground up, which was unique to me because when I came into this and when I was learning about it, kind of and hearing about it, when I was at Pivotal, everybody else at this point, even Netezza and everybody, had taken Postgres or MySQL and forked it, and then stuck an engine on the back of it and tried to make of it. But because this is truly, from the ground up, built a new database for the cloud, we can do some of the unique things we can do. Roughly coming up on $1 billion in funding. On Monday, we announced we actually have a new CEO as of Monday. Well, I say what is today? Yeah, so Monday. Yesterday actually is when we announced it. A guy named Frank Slootman. He was the CEO of ServiceNow when he took them public. So you guys, some of y'all may have met Bob. So Bob is helping through the transition, things like that. But Frank is kind of here to take us to the next level, and that'll be just growth from where we are right now to he took ServiceNow from $100 million to $50 billion. And so that's where we hope to be pretty soon as well. So we've got over 1,800 active customers now in the Gartner and Forrester leader quadrants. But why we built what we built, obviously the current problems that are out there that everybody here probably well knows from a data warehousing perspective. Siloed, diverse data. Everybody who's done anything with any sort of MPP platform up to this point knows the shell game that comes around with trying to decide when load windows end, if they overrun. How do I get more than 10 people running a query on a system at a time? It's a nightmare, right? And so Snowflake was built to resolve those issues and kind of take a different spin on this and take advantage of the cloud, right, as well, and just all the architecture that's out there. We can talk more about the specific functions and pieces of the cloud that we use here in a while. But being able to scale up, scale down, both size, horizontally to any kind of workload, that's what we're about, right? And that's what makes it makes us unique in the market. And we also are only charging you for what you're using, right? So after 5 minutes, you can turn your clusters off if you'd like, and you're not being charged for it, which is unique as well. Other cloud competitors out there, your Redshifts, BigQueries and things like that have similar features, but there's some complexity that comes with actually copying data. Where I would argue that when we get into it, we can talk about it. I would argue that probably the things that make Snowflake the most unique are our service layer, where we can actually have all that compute to spend, but also our storage layer and how we utilize S3 as our storage layer, so it makes it very robust and very cheap, but also the ability to actually do zero copy cloning and time travel. If y'all who are familiar with it and use the tool currently, being able to take a query today, run it, and then tomorrow run the same query and see the results as data changes over time within a given time window is a huge deal. And the engineering task that was to actually kind of accomplish on the back end is what is truly probably the most difficult thing that they had to overcome and solve. So that's a unique thing that I think you're not going to see in any other competitors. But ultimately the goal is to make all that slow, limited decision making go away. So, and like I said, we built centralized data, unlimited automated scale and speed on a simple, cost-effective infrastructure. Sadly, as a consultant and at one point in my life, actually a full-time employee, when I was working in data warehousing groups, my time was not spent doing fun stuff. It was, building indexes or tuning queries or stuff like that. And that's what we want to get people out of that, because it's in my personal opinion, it's a non-value add in some respect, because what you're trying to do, particularly for those of y'all in the oil and gas industry, right? Really trying to get insights out of that data instead of making reports run faster or timely, that's where your time and effort's going to be. And that's what we're helping people do. At the end of the day, the economic buyer of this product are the ones who can actually see value faster from it. Not, it's great that it's scalable and do all those kind of things, but the business outcomes that we're allowing people to achieve is why people are really flocking to us. So, the legacy architecture before, some of you guys who haven't moved to Snowflake, you may be here at this point, you've got plenty of data sources, and you usually have some centralized EDW on some platform with a data lake or Hadoop down there, and then you have your data marts off to the side that have to be built because nobody wants to be hitting the main EDW, so I go build my little shadow database over here and pull data extracts from a couple of times a day, and you end up with data all over the place. So how we fix that problem is through our concept of virtual warehouses. So we talked a bit about the storage a minute ago. Storage for us, it's the same as any other SQL database. Databases, schemas, tables, views, all those things, right? And you can have one or more databases where you actually store your data, but they're completely separated from the compute layer. The compute layer we call virtual warehouses, right? And that is where we can scale to deal with both concurrency horizontally as well as scale up for just extra speed. And you look at it a lot of times, we can talk maybe later just about some use cases, how folks here are using it currently, but how we usually talk about this is we talk about it with respect to the role that you're playing and the actual function that's taking place in the warehouse. So in this kind of picture here, we've got the cogs being different sizes of virtual warehouses, right? And those virtual warehouses, the data science side, what we're kind of here talking about, on any given day, you may not need to do a whole lot in the database, but when you do need to do some complex feature engineering or some data cleansing and things like that, you don't want to wait forever to do it. So we allow you the ability to scale that up on instantly on the fly and say, all right, now you have more compute. It's going to, I get that job done faster. I'm going to engineer those features and be done with it, right? And then when I'm done, I can go and scale back down. Other customers, use it and they have just a dedicated ETL, ELT. So one of my customers is Neiman Marcus down in Dallas, and they actually have multiple ETL kind of warehouses that they work off for different things because they're loading stuff throughout the day. But the great thing for them, right, is they've got these big warehouses that allow them to process data that they were putting into Vertica much faster than they were. And they're now putting it, throughout the day, whereas it was a once a night load in Vertica at one point. But what, the great thing for them is they can have this very fast ETL process running, and then that's running, and then when, it's not running during those parts of the day, it suspends and they're not being charged for it. So that's like a great thing for them, right? And so it helps cost containment. Outside of that, you can do horizontal scaling, BI and analytics, so you can have a lot of people on the system who may not be, using a lot of CPU power, but you've got a lot of concurrent queries. So your cloud providers out there, Redshift, any of your, kind of box solutions like Netezza, Vertica, or anything suffered terribly from concurrency issues, if any of y'all have worked with those. All right, so, and again, the whole picture of what we do, we end up with situations, where, again, we use and we work with pretty much any ETL, any BI tool, lots of data science tools out there, and you end up with, kind of different warehouses out there of different sizes for different purposes and uses out there. And so that really allows you to unlock, the data to your customers internally and not have to worry about, again, contention or load jobs running long or something like that. So, at this point, I've got a lot of different we'll go through a few more slides just from a technical deep dive perspective, and then we can do a demo. I'm happy, those folks here who use Snowflake, if you've got questions you want to dig in further here, feel free to ask me. Those of you who are new, ask away as well. So, but, again, a big difference for us, traditional architectures, shared disk were out there, your SQL servers of the world, your MySQLs, shared nothing came along with Netezza and Vertica and everything, but we're truly a multi-clustered shared data architecture, so you have no problem there. What we have here, though, is, again, we talked about storage separated from compute that allows you to resize instantly, which is a huge deal. On top of what I talked earlier about the two things that I think were probably the most difficult engineering tasks in building Snowflake, one of them being the storage layer, and then the second being this database services. And if you think about what Snowflake is really at its core, the data, storage layer, that's S3. We put our own spin on it, and in Azure, it's in blob storage down there. So that's kind of like saying, when the compute layer, we spin up and down, we spin down those computes. I mean, behind the scenes, there's virtual machines that are using that compute. But this database services and the metadata layer that we provide is actually, if you want to think about what Snowflake is, that is what Snowflake is. So that allows us, it handles all of our connections and all of our optimizations of, where your query is going to a specific warehouse. If we have, different types of caching going on, how that's going to do, it handles the ACID compliance, the transaction management. So if you've got 50 warehouses running out there, and you always want to make sure that when you run a query, that from an ACID compliant database, that when you make a commit, all of those 50 warehouses see that commit at the same time. That's what that layer takes care of. Lots of metadata in there, and then obviously security is a huge deal, and we manage it all through there as well. So we'll show you what it looks like to log into Snowflake here in a bit, but that's the database services are what really make Snowflake, if you will. A deeper look into kind of what it looks like from just an architectural standpoint. Database storage at the bottom, like we said, virtual warehouses again, and you'll notice that we do have caching in there. So one thing that we do to actually speed up performance is, everybody probably knows, blob storage, S3 and Azure. Blob storage, not the most they're not meant to be performant, database, like storage structures where you get lots of data in and out fast. So, on cold reads, we do read from those. It's still actually pretty performant because when we load data into there, we columnarize it, we compress it, so we do all the typical stuff that you're going to do. But when you actually query data into a warehouse, we do have levels of caching in our virtual machines and our virtual warehouses, and so that data goes in there. And so, again, I've been here a short time, but a lot of our customers do things, you guys may be doing it as well. You actually get in the morning after your ETL load's done. You actually just run an entire query to cache nearly your entire data set inside those virtual warehouses because it lives for 24 hours. And so results are almost instantaneous at that point because it's stored on memory and an SSD at the virtual warehouse layer. And you don't have to worry about, the complexity that you have to deal with there is just you running a query, and once that query is run, it's cached and stored, and you're fine for 24 hours. So there's more complexity to that, but you can get into some kind of, again, unique scenarios where, for better or for worse, you can actually use less Snowflake compute because you can run that big query once, and then you get more, you actually can basically cache a whole bunch of data, and then you're not going back to the well. Like with small queries, you can have them all come from that one big cache at one time. So it's good for y'all from a sales perspective. A little painful, but yeah, separate storage and compute. Let's see here. Sliding y'all to death. I don't want to get into that. So we'll do this. We'll talk real quick about this. How many of y'all have JSON or XML data that you're working with currently? You have JSON? Are you guys using the JSON, the variant column? So the unique thing about Snowflake is we have so in our world, JSON's a first-class citizen. We have a data type for one of our columns called variant, and you can actually store JSON objects directly in that column without having to break it up, and I'll show you a demo of that here in a minute. And you can query it with SQL very easily, which anybody's ever tried to take JSON and actually write an ETL routine to parse it out and put it into a flattened structure, it's a nightmare, right? And so this makes it very easy because you can store it just natively in there. Some interesting things about this for existing customers to know and everybody to know. So we support JSON, Avro, XML, Parquet, and Orc, but you bring those into Snowflake right now, and within, I think, maybe 2 to 3 months, we're going to release what we call external tables, which actually is much more akin to, if any of y'all have used Athena from AWS, where the data still resides in S3, and you can use Snowflake compute. You don't have to bring it into Snowflake. You can just read it directly from there. And it's different than like reading from a stage or something like that. You can actually read and do it on top of there. Performance, the performance is not as good as when you load it into Snowflake from that perspective, but it's a new unique feature that I think, particularly in data science and AI, you're going to see a lot of that use because, again, data scientists want to just play with data, and that's an easy way for them to get at that data and do that. So that's a new feature, but it still supports all the same semi-structured data that's out there right now when we do that. Data sharing. This is something is unique. I think we're going to see more of it when we start talking about some of the, not giving up some big secret here, but at some point there's going to be a marketplace for data within Snowflake where you can go pick up data from other people and actually bring it into and they can share it with you and you can bring it in yours. So which is great for data science because if you've got weather data, if you've got census data, whatever that kind of data you're trying to munge with your own data to make some sense of it, within Snowflake, it's just a matter of a couple of SQL commands to share that data with you, and you have full access to it. And vice versa, you can share it with other people as well. So that's a pretty neat thing to do from that respect. And you can get live access instead of having to do FTP files across the wire or something silly like that. The comprehensive data protection, we can talk about that in a minute, but I do think the other great thing about this is, from the respect of being able to enable your organization, our comprehensive data protection and the ability to do what we call zero copy cloning is a huge deal because you can actually, if any of y'all have ever dealt with having to, refresh your lower environments with data. So that's usually like a quarterly thing or a yearly thing. I don't know. It depends on the business, right? But, it takes time to take a whole copy of a database and move it to test, move it to QA, move it to whatever. With us, it's purely just a single SQL command to do that because of the way that we manage storage on the back end. And you can make unlimited versions of dev environments or test environments or whatever on the fly for specific purposes, which is great even for data science and machine learning because you could actually just take an entire copy of your production database and make a copy of it for the data scientists to do whatever they want to do, and they can change the data if they'd like, and then when they're done with it, they blow it away and it's gone, and you're not messing with the production system out there as well. So, all right, so maybe I'll just jump out here and we can go through some some demos. So to show you what, you know, the main, I'll call this maybe the main way that, you know, we always work with Snowflake. I mean, you can connect to Snowflake with any ODBC, JDBC driver, you know, .NET, Node.js. There's plenty of ways to connect to it. The Snowflake UI is where a lot of people come in to use with it. You can use database query tools, visualizer tools as well. I'm curious, what y'all who use it right now, do y'all use the UI much, or do you use like dbeaver, or what do you use to actually to query it?
I mean, from Sonic, we just recently spin up, so we're
Yeah.
mostly doing UI.
Okay, cool.
But we also use
Yeah, yeah. So interesting thing about the UI, I actually like the UI pretty much, but we are gonna have a lot of new kind of enhancements to that as well, where there's gonna be some things where you can even do some, you know, it'll have the auto completion, it'll have all that fun stuff. There's even talk about having like simple charting and histograms and things like that, which again is very useful for, you know, data scientists who want to do that type of, you know, just sampling of data and seeing what kind of data exists within a table, right? So you come in here to Snowflake, you know, across the top here, this is our concept of databases. Think of a database just like you would, if any of y'all are familiar, you use SQL Server as an instance, you create a database in SQL Server. Within that, you can have schemas and tables. Same concept here. I mean, there's, you know, it's not, you know, nothing unique or new about that. You know, behind the scenes, what's happening when you create these things, the data is being stored within our proprietary, you know, format within a S3, so it's performant and it's, you know, columnarized and compressed and everything like that. But you create those databases, and then you can create warehouses over here. So remember, there's two separate concepts. The separation of storage and compute. Databases, where you store data. Warehouses, that's where you compute. So yeah, warehouse can read from any number of databases, one or many, and you know that's kind of the secret sauce here. So, and to create a warehouse is very simple. We just go here and we'll create one called load warehouse. Some notes about this: when you create a warehouse, we have, you know, various sizes here, ranging from extra small to 4XL. You know, since I've been here, a lot of people use, like, they get such good performance with, you know, on most cases with small or medium, and some people even use extra small. I haven't seen anybody, what do you guys use, any of the big 4XL or anything like that at this point? No? So, yeah, I'm not sure that anybody does, which again is great for y'all, but because it's so performant, we just don't have to use that much horsepower. But you choose your size of your warehouse here. You can set your clusters. You can scale it horizontally from, you know, 1 out to 10 to deal with the concurrency issue. So if you've got a lot of users hitting it, that scaling out and both up and down is done automatically. You don't have to touch it or do it yourself, and it's done. You know, when it's doing it by watching how much load is on the system, and when new load comes on, it starts adding clusters to it up to the limit that you asked. And when that goes away, then it shrinks it back down. So it's all taking care of it for yourself. And then the auto suspend, like I said, you can basically set that auto suspend to 5 minutes, or you can actually set it even to less than that if you want. But so once the warehouse is not seeing any queries there, it goes to sleep. When it sees a query come in, it wakes back up. You know, when you look at these, the size from basically up to like 3XL, all of these pretty much come back alive within a second or two. And then when you get to 3XL, 4XL, it's a little bit longer, a few seconds, but still, in the grand scheme of things, that's pretty all right. But what's cool about this is it's all done. That's a nice little kind of wizard that allows you to do it. You can do it all through SQL commands, which is you can get flexible with what you want to do. This comes into play, you know, really well when you have an ETL routine, because what you could do is you can have your, you know, if you have your ETL job that runs every day and it's like a big sequence of events, all you got to do is at the beginning of that ETL job, submit a SQL query that actually sizes up the warehouse that it uses. It could, you know, it could size it up to, you know, 4XL, so it runs really fast. And then all that stuff runs super quick. And then at the last step of the job, in the ETL job, you just size it back down to a small, so you're not paying for it anymore, right? So, and you know, that's just one case, but because it's all done through SQL commands, you can kind of start embedding those things in a lot of places. You can embed it into, I used to work for MicroStrategy, and they had a concept of pre and post SQL statements. So like before a report would run, you can run SQL statements and you can embed that in there, hard code it. And so there are customers we've seen who actually have, big gigantic reports that take a long time to run, and when people, they don't want that to take a long time, so they do the same thing. Before the report runs, they scale it up, it runs, and then they scale it right back down. So, and it happens throughout the day, hundreds of times. They scale it up and down, but there's no impact to doing it. You can sit all day long and change the size if you want. It just costs money when you have more credits. So finish that up. So the warehouse is created at this point. And from here, we can go in here to worksheets, and we can do some things. This is a simple demo. We can load, let's see here. Well, basically, what we have here is we pre-staged city bike data. So I think you guys have, what is it, Lime bikes here? What are the scooters? I was here a few weeks ago as an aside for my cousin's wedding, and I saw a lady, and she was riding it, and she like ran into a light pole. I was like, oh my God, it was just like not paying attention. But anyways, so city bike's kind of like Lime bike or any of those things, and they get, it's just the data in there, and it shows all the different trips and how long people were on there. So we've staged this data actually in an S3 bucket, and you can see, sorry, I'm on my phone here, so the connection's not terribly great. But you can see what we've staged is just a bunch of CSV files that have been gzipped out there. And what we're going to do is we're going to copy those. Those are in what we call a staging environment. So they're in a S3 bucket in AWS. That staging environment we can have both an external and an internal stage. An internal stage is basically you use our platform and you can load data through Snowflake into that and just raw format. Or if you already have S3 buckets of your own and your own kind of AWS tenant or your Azure tenant, you can just set up the policy to actually let us read from those, so you don't have to move the data from where you already have it, which is pretty nice for people who've already staged lots of data into some cloud environment. So we'll copy those trip files, all of these, but you can see I've just got a regex pattern on there. I'm just going to copy the ones for 2018 directly into Snowflake. So it's using it right now, and I just pull, while that's running, you can see over here, we keep history, good metadata on pretty much everything we do. And here we go. So you can see right now we've got, this load coming into here. We can see duration, how long it's taken, how many bytes we've scanned, how many rows it's in there. So what is that, 7.6 million rows in 5.8 seconds. So it's, it all depends on what kind of data you're using and loading, but it's very quick to actually get data in there. So we've loaded that data. We can see, we've got 7.6 million rows in there, and then you're off to the races, and you can pretty much do any of these, any kind of SQL statement, since we're ANSI SQL compliant, that you want out there. Our SQL dialect is a superset of ANSI 92, meaning that we cover all the ANSI 92 stuff, but we have our own kind of specific functions within Snowflake that we do, and we'll show you one of those in a minute. One of them is actually the Haberstein function, which is an estimation of actual distance between two latitude and longitude points out there. So that's one of them, but you can just do those kind of things. So, all right, and then so SQL is great. You can use SQL. You can also pop open Tableau, or Power BI or Click or any of those type of things. And this Tableau workbook is off of that, and it actually is using a live connection. It's not a TDE or anything like that I'm caching in there. And come back, and so it'll just pull very quickly again all of the data into the workbook, which is and I've seen a lot of data scientists and AI folks and ML folks they like to use Tableau just from a visualization purpose, and I'll show you how to connect. We can connect Python or Jupyter to it here in a minute as well. Show you what that looks like. So, sorry. It's slow internet today. So, anyways, there we go. 10.6. So, simple stuff, but where the things get really kind of unique is when you start talking about, again, semi-structured data. So this is where I think from a AI ML perspective, things would get really interesting. So here I'm going to show you how we're actually going to take we're going to clone that entire database that we have out there with those 7.6 million rows into a dev database. It'll take a few seconds here, and then so it's cloned at that point. We haven't actually used any other storage. We haven't made a copy of it. We've just done what we call a clone, which if any of y'all are familiar with how data is stored in a database, really what's happening under the scenes is we store data at the block level, and then when you make clones, you're actually putting pointers to the existing blocks that are out there, and we can, whoever wants to get into that detail, I'm happy to talk to them about it after this, but it might make people's eyes gloss over. So we'll create another little warehouse out here. And we'll look at some of this weather data that's basically JSON, again, JSON gzipped out there. And if we look at, you can just, so that's in the stage, we can query directly from the stage just to see what the raw data looks like. While that's querying, I'll show you, this is, it's probably kind of hard for you guys to see up there, but this is just what one of those JSON objects looks like. It has the, it's a couple levels deep. You've got city, coordinate, latitude, longitudes, where it's at, and then basically what it has is, at that particular point in time, what was there? Was there clouds? Was there snow? Was there something like that? So what you can do with that is you just load it. You can create a simple table where all we have is time, two columns, timestamp and the variant column. The timestamp is obviously, the time that particular measure or weather reading was taken. And the variant column has that entire JSON object for that row in there, for that piece of time. So we created the table, weather, and then we're going to set our warehouse to large because we're going to load a bunch of data in there. So we're going to set it to large real quick, get it in there. And we're just copying into that table basically all those gzip JSON files from there. Take a few seconds here. And then what we're going to come down here and do is I'm going to show you where you can start actually just using select statements, and in your queries actually start traversing that JSON tree. So while that's loading, you can look at this down here. What I'm going to do is I'm going to basically say, all right, so now we've loaded all that. We'll make our warehouse small. And so we've got roughly, 21 million records in there. So what we'll do is we just want to find the first 20 records of those JSON objects where the city name's New York and it was snowing, okay? And so if you think about what that would take, so if you were to not have this capability with this variant column and the ability to actually kind of parse out the JSON object and query on it, you would have to actually build some sort of ETL routine to flatten that into a table, load it all into the table, and that gets very complex, right? And, or you'd have to have some, complex Python, or you'd have to write some way to actually do that, and it's not the easiest thing in the world, and most people know SQL. So because now we're just doing this, and because we can, with the where clause predicates, basically say these nodes of that JSON object are these, it actually queries through there and pulls that back. I mean, for those of y'all who you worked with JSON before, you realize how powerful that is, but believe me, if you've not, it's a gigantic pain. Like, this is amazing to be able to do this. And you can, from there you can do other things like that, other things like saying, okay, we're going to actually look at all of the records in there, and we're going to use a flattened function. So what we're going to say is, in this second query, we're going to say, show me the frequency of certain weather conditions within certain cities out of all 21 million rows there. So basically, you can see up here, we're basically selecting, here's the condition, and we're saying how many times did a particular condition exist in New York, Seattle, San Francisco, Miami, and Washington. We're going to flatten that out. Again, this is something, and this type of query is something that data scientists do all the time, looking at frequencies and data within a particular item. What's up? Oh, sure, what's up? Is there going to be a GitHub repo for this demo by any chance? A what? Is there going to be a GitHub repository for this demo by any chance, or any way for users to go through it? I can certainly, I don't have one right now, but I can certainly work on it for sure. Yep. So what we've done here is now we've just looked through 21 million JSON objects out there for New York, Seattle, San Francisco, Miami, and Washington, and found the frequency of these different conditions out there: drizzle, clear, haze, snow. I mean, that's, again, when you get into looking at lots and lots of data, and you're trying to build machine learning algorithms and do feature extraction and stuff like that, and feature engineering, this type of functionality, particularly on for those of y'all who in the oil and gas industry, I've actually been working with some guys to actually do. I would like to get WXML to be kind of a supported object in here as well, which is very similar in some respects to JSON or XML. But you can start doing those type of things in here, and you can even go down here and you can take semi-structured data and you can join it in a view with structured data that you have already out there. That's very powerful to basically be able to bring in semi-structured data and not worry about building huge ETL routines to do that. Some other things real quick, again, we talk about data protection a lot in the zero copy clone. The great thing about this so what we mean by that is with the standard version of Snowflake, when we write data to a database, we write what we call immutable blocks of data, right? And so those, in the standard version, they stay around for 7 days. What that means when the rubber meets the road is you have the oops moment and you actually drop an entire table in a database, which has happened to me in the past, and in production, it happens, right? Or you run an ETL load that really screwed something up, right? How do you recover from that? And then in today's world, a lot of times it's going to backups and trying to restore backups, and it's a big pain to do. But here you can, if you drop this table in Snowflake and it's not there anymore, because we have the continuous data protection feature, we can just do a simple undrop command and that table's back, right? So it's not, there's no going to the DBA and getting, backups and things like that. Other cases, dropping a table may be extreme, but if you delete from a given table or, a specific set of rows, so from this table we're going to delete, actually from trips, we'll go ahead and load more in there. Got to load more data into this to show you real quick. So we'll load a bunch of data into this table and we will delete, well, maybe not. Well, was going to show y'all, but we're having some problems here. So, but the short version of it is that you could delete from this table basically, rows, and then you can come down here, and because we keep history of what we do in every statement that's in here, you can actually find a given statement, and you can go back and you can reset the world before that statement ran. Meaning, within the time frame that you have, and we can go in within the enterprise version, you can go back and you can have 90 days of history. So you can have 90 days of oops room, like if you actually screw something up. So you can basically say, you can run queries and you can say, show me what the world was for this query before a specific query, another query ran, or a specific time of day, or something like that. So it allows you to restore data. It allows you to actually run queries and see what data looked like when data changed over time. This is pretty big for, surprisingly, for month-end close for a lot of folks in BI departments, because every day, as you book new entries into a journal and things like that, they want to see kind of what the change and how those books changed in the first couple of days when they close. So, and if you've ever dealt with ERP systems, they have very complex ways that they actually get around doing that, and it's a big pain. But this makes it super easy to run reports for people and say, the first day of the month, here's what the book's like. The second day of the month, here's what the books look like. Those type of things as well. But a lot of other ways that you can use this feature, and that's something unique to us as well. Aside from that, we'll leave some time for questions, but I did want to show you, since we're talking AI and machine learning, here I've set up just a simple Jupyter notebook. It's pretty simple. We Python, Spark, all those things are supported with the connectors there. Sounds like you guys maybe are using some Spark already. No, not with that yet? Okay. But, there's a lot of features on the roadmap that we're going to do there. But, you can easily, pull from Snowflake with any of these connectors. With Python and stuff, it's just ODBC, JDBC connectors, but we're getting more and more native support all the time. But you can come in here and with, pretty simple, Jupyter notebook, just run this, pass in your credentials. And create a quick import. You have libraries that you can import for us that are all out there in Maven and everything like that. So you can import the Snowflake connector, create your account, and then just run anything from simple SQL statements in there to more complex, is whatever you kind of want to run at the database level. But very simple to do that kind of stuff. So yeah, I'm happy to, I know some of you guys obviously know Snowflake pretty well. Some of you don't. There are other features I could show, but does anybody have any specific questions at this point? All right. So I guess I'd ask maybe for those of you who are using Snowflake right now, kind of, I'm interested to hear, as kind of new to Snowflake, goods, bads, whatever, right? So how are things going with it? And where are you, so you're from Sonic, right? So where are you guys moving from? What platform? Are you moving from Hortonworks? Is that right, or?
No, so we were so we're on AWS.
Mm-hmm.
Previously using a lot of VMware, people,
Yeah.
and Redshift. So moving to Snowflake from that, I can certainly say it's a huge improvement over Redshift.
Sure.
In terms of scalability and cost, not having to
Run all the time. Yeah.
a lot of connectors for Snowflake.
Yeah.
A lot of different products that seem to be connecting to it really easily.
Yeah.
Supply chain delivery.
Cool.
It's really powerful.
Gotcha. How about you guys? You guys so far so good, or how far are you in your journey at this point? Yeah. Right. Yeah. Yeah. I mean, yeah. Spark, Hive, those are all great tools. I think that they're complex and they're a lot to deal with on a day-to-day basis, right? And again, I think people, most users out there from the business perspective, SQL is just easier than trying to learn how to do Python or something like that, right? So, and it gets them what they need pretty quick. So, yeah. So, I mean, in a nutshell, that's Snowflake. Kind of what we are, what we do, how we different. We got a question? Yeah.
I'm going to ask you a repeat question. Is the rollback feature rolling back to a point in time, or is it rolling back to a specific period like the transaction?
It is rolling back to a. What's up? Yeah, so it was basically asking, is the rollback feature basically before, like, to a point in time or before a query? So I would not call it really a rollback feature in some respect, because a rollback implies that you're actually modifying the actual data, the blocks of data that you've stored. So because and again, it gets into a complex thing where we talk about we store immutable blocks of data, we're actually just altering so if you do it based on a query, you're kind of looking at rolling back as the world was before that query, and you can do the time. So you can do both, but I would be careful calling it just a database rollback in some respect at that point. So. Sure.
So say I have a data warehouse from scratch, makes sense. What about like conversion? Do you guys have any sort of tools or utilities to take an existing data warehouse and convert it into Snowflake?
Kind of depends on the warehouse you're coming from. Yeah, so the question was from moving, standing up a new data warehouse is one thing, but moving and migrating from a existing data warehouse over to Snowflake, do we have anything that kind of accelerates that, right? And so depends on the actual, like, where you're coming from. So I know that with Teradata, we have some, there are some tools internally that we can use that can help move that over. At the end of the day, I mean, the big, where the trick comes from with that is DDL and just the structure of the database. That's all pretty easy to move over. It's when you get into situations where you have a lot of stored procedures and stuff like that, where that's where the actual kind of effort takes involved in the migration. And it just depends on the platform that you're moving from. But we actually went, so stored procedures were not a feature that we had until I think 2 days ago. We actually went GA with them. So if you guys haven't seen that out there, you should see it in your account now. And you can go out and store. So our stored procedures, we chose in the beginning, they're written in JavaScript, which we found to be, kind of, again, that's like everybody uses JavaScript for all sorts of stuff nowadays, but it's a much more, kind of programmatic friendly language. So yeah, those got released just a couple of days ago. And that's the nice thing about Snowflake, because it's a service, it's not like you actually have to go update anything, it just shows up in your account one day, and that's pretty nice. So yeah.
So instead of migrating our databases, we're replicating them with Fivetran.
Okay.
I know that Devin uses it too.
Yeah.
And we get a soft delete. And we're thinking about wrapping that in potentially a view.
Yeah.
So this is what the database actually looks like
Sure.
table, all soft deletes assigned to them. I'm curious about what you thought of that area. What is one way of managing soft deletes?
So I mean, yeah, that's a pretty standard way to do it in a warehouse, right? I mean, yeah. So the question was, they have a situation where they're doing soft deletes in a table, and so they've got a view on top of it that actually filters out the soft deletes to show the actual, kind of true state of the world, but they have the raw data behind it, so they can go back and see what that was at any given point in time. So that's pretty standard stuff. I mean, there's nothing particularly different in Snowflake that I would do to handle that. I could think of, it depends on how often those soft deletes come in. If they come in a batch type mode, then you might actually be able to take advantage of some of the data copying functions to get rid of the view and just physicalize the entire table, even through because we actually released materialized views about a month and a half or 2 months ago as well, I believe. And so you could do that with the materialized view, and it just depends on how you want to do it. But if your performance is good right now, it's just a view on top of it, I would say keep it that way, right? So, yeah.
And we have no idea what the performance is.
Oh, okay, so,
We're
yeah.
just trying to use it to replicate.
Yeah. So, yeah, you would have to see what when the performance in particularly, because that's just going to be almost like a binary flag, yes or no. You're not going to do a ton of partition pruning on it when you actually, at the database level, no matter what you're doing on that. So you'd be interested to see, but I doubt that it's going to have a massive impact on performance in a poor respect. But it kind of brings up actually a use case. So I did want to show this, as you can see. So just while I have this up, we do have a lot of actual, for such a young database, we have a lot of functions that are built in there that would be useful for AI and machine learning. Lots of cardinality estimations. We do have inbuilt linear regressions, but the frequency estimations, percentile estimations, and those things. Once you're starting to deal with big data sets, and then if a data scientist is trying to understand what size they want to sample of that, they use these type of functions to do estimates of what the population looks like, and it's much faster than trying to, if you've got a trillion row time series table trying to do an actual query on that, you can do a lot of these estimates are what come into play for data science and machine learning. And actually, for those of you in the oil and gas industry, I found that Snowflake is actually a very compelling time series database in that. And the reason for that is, so for those who aren't familiar, there are specific databases whose sole function are to take time series machine generated data, and they're very, they're like very tiny seconds or microsecond data, and it's just boom, 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 and it's ordered. Well, with us, because of the way that we do our partition pruning and some of the actual kind of when you actually submit a query and how you actually optimize it, we can get highly, highly granular partition pruning and optimization on that time series data, because it can be trillions and trillions of rows of little individual events, but we're able to efficiently slice down little windows of that, and more so I think than we've got some things coming out on it, more so than actually some time series databases themselves. So pretty interesting. So question?
Are there data connectors or Azure data factories or something?
At this point, I'm not aware. Yeah, so the question was, are there connectors for Azure Data Factory at this point? I don't think that there are. They're in the works, I know that much, but there's not at this point. You can still use, we have people using Data Factory with it, but it's not like a native connector at this point. I think it's just ODBC connections, so.
So when you're running, say, transformations in Spark, with Databricks, how do you manage, hey, this would be much more effective in Snowflake versus the Spark SQL engine? How would you manage that?
Yeah, so the question would be, so if you're using Spark, and so you're doing like data, you're talking about more like ETL data processing techniques and things like that. It's in some respects I'll say it's a question of taste and where you've got where your skill sets lie in house, right? If you've got people you got a bunch of Python, PySpark guys, you got a bunch of Scala guys, okay, that's one thing, but I still argue that SQL is kind of like the lingua franca of data in some respects, so it's a great way to do that. And Spark itself is a very it's like a general purpose computation engine, right? So it's going to do certain things pretty well. And it's going to do, for machine learning and data science, it's great, right? Because you can iterate over the same data set, without having, it's very computationally, good from that perspective. But I still think, I would argue that the, true ETL, ELT processing should be in a database, a proper, like an actual, a SQL ANSI compliant database. So.
I guess let me see if I can ask my question clearer. So I'm executing in Spark.
Yeah.
Right? But I'm doing a join that would just be so much more effective in Snowflake.
Sure.
And then an aggregate, and then get the aggregate, and then put that in the database.
Right.
So is there a way to say, hey, I want this query to occur in Snowflake, give me the results of that query, as opposed to giving all the data and then the query and then do the join inside that database? Is there a way to push that down in Snowflake?
That is a good question. So I do believe that there is a way. Yeah. So the question was, can you push down, certain particular type parts of a Spark job or a Databricks job into Snowflake that would be much more, efficient in a database than in Spark? And the answer is, I will have to get back to you on that. So yeah. There you go. All right. Cool. Well, all right. Oh.
It's not a question, but can you put up the contact information slide for the screen then?
Sure. Yeah. Yep. Well, I appreciate everybody coming out today. Thank you very much.